How many?
4.
3, 4 pages. Okay. Right, next. The third method of preparation of aldehydes only using Dibal H. Using Dibal H. What is Dibal H? Dibal is diisobutyl aluminium hydride. Okay. So please write first of all nitriles and esters. Nitriles and esters. Can be reduced by mild reducing agent. Such as Dibal H. What is Dibal H? It is diisobutyl aluminium hydride. Nitriles and esters can be reduced by mild reducing agents such as Dibal H, 2 imines, and on further hydrolysis, they give aldehyde. Okay, so please write. First of all, what is Dibal H and what is the structure of Dibal H? So aluminium, it has a valency of 3. That means it will be bonded with 3 different atoms. One of the atoms is hydrogen, and this is the hydrogen which reduces the nitriles and esters, and that's why it's a reducing agent. Then we have diisobutyl. Butyl means 4 carbon atom, and it is connected to the isocarbon. So this is 1 carbon, 2 carbon, 3 carbon, and 4 carbon. Okay, 1, 2, 3, 4. So this is diisobutyl aluminium hydride. So when you have RCN, in the first step we will give Dibal H. Second step we will give H2O, just water, and you will get aldehyde RCHO. For example, even if you have any unsaturation, so it is not going to hinder any unsaturation here. It is just going to reduce this nitride, giving you RCHO. Similarly, if you have double bond O, OCS3, using Dibal H and then water, it is going to give you C double bond O as it is. This OCS3 will be replaced by hydrogen. So please remember 1, 2, 3, 4 carbon atoms till the carbonyl carbon. So you'll have all the carbons till carbonyl carbon. After that, you are going to get a hydrogen instead of OCS3. Please write this down. हनीफा आपने टेस्ट दिया था फ्राइडे वाले दिन?
No, sir. Don't explain that. Wasn't.
Okay, could not understand what, but I could at least get that you did not give the test, right?
Yes, sir. I wasn't there at that time, so I couldn't give you.
You are not well that day or you did not prepare? क्या बोल रही हैं आप? आपकी आवाज ऐसे क्यों आती है? आप माइक कितना दूर से बोलिए.
I wasn't in my city that I was out of city. That's it.
अच्छा, you were out. Okay, fine. Okay, right, next.
Sir, so the Stephen's reaction and this one is very similar.
In terms of products, yeah, right. In this reaction, we are using this Debal H. Okay, using Debal H, you can convert two things: nitrites also and esters. Both of them you can convert to aldehyde. But in Stephen reaction, we use different reagent, right? है ना?
Yes.
Right, next, fourth one. Etard reaction. In Etard reaction, please write alkyl benzenes are oxidized to benzaldehyde with a solution of chromyl chloride in CCl4 or CS2. Both of these are non-polar solvent. Please remember, ये जो आपके पास यहाँ पे हमने reagents लिखे हैं ना, these are not reagents. ये जो हमने chemical compounds लिखे हैं, these are solvents. So we need a non-polar solvent to stop the reaction at benzaldehyde. Otherwise, that is going to get oxidized completely, and you are going to get benzoic acid rather than benzaldehyde. So to stop the reaction, we use a non-polar solvent, CCl4 or CS2. So please write a brown. First of all, what will happen? A brown sorry, chromium complex is formed which is decomposed by water to give benzaldehyde. If you have CH3 here, this is methyl benzene. In the first step, I will have chromyl chloride in the presence of a non-polar solvent. Formula of chromyl chloride is Cr2Cl2 in the presence of CCl4 or CS2. Then we are going to get a chromium complex. The chromium complex looks like you have the benzene ring as it is. CH in bracket you have OCrCl2 OH whole twice. This reduces, this is brown in color. On the addition of water, it's going to give you benzaldehyde. Now, also it does not matter what is the chain length, even if you have a bigger alkyl group attached to benzene ring. For example, you have CH2CH3. Then in this case also, you don't need to worry. This can also be converted to benzaldehyde. in CCl4, and first step, second step is water. Benzaldehyde, CHO. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Right, next. Using chromic oxide with acetic anhydride. Fifth one. Chromic oxide in acetic anhydride. Right, number one. Treatment of alkyl benzenes. Treatment of alkyl benzenes with chromic oxide in the presence of acetic anhydride gives aromatic aldehydes. ठीक है? Please see. In this reaction, we have the same methyl. We have the same methyl benzene. The reagent that we are going to use is CrO3 at somewhere around 273 or 283 Kelvin. That is going to give you 0 to 10 degrees Celsius. And then you have CH3, CO whole twice, oxygen. What is this? This is anhydride. What is the structure? You have oxygen here. Oxygen will have two different groups attached to it, two bonds at least. Now both of these bonds will have C double bond O, C double bond O. ये आपका CO हो गया directly connected to oxygen, and then CO is then connected to CH3 here and CH3 here. Okay, so this is known as acetic anhydride. This part is acetic, and both of them are what? Anhydride. That means there is no hydrogen here. It is not acetic acid. If you remove the hydrogen, you will get acetic anhydride here. Okay, so this is acetic anhydride. Then, first of all, it forms. Please write CH OCO CH3 whole twice. This is benzylidene, benzylidene diacetate. Then hydrolysis in acidic medium, it gives you benzaldehyde plus 2 acetic acid, 2 moles of acetic acid. Done everyone? Yes or no? Please tell me.
Yes.
Right, next. By side chain chlorination. So sixth, I think. By side chain chlorination. Now, first of all, see what happens here. We have a benzene ring like this. Okay, CH3. If you remember preparation of haloalkenes from alkenes, there is free radical halogenation. So free radical halogenation happens here. So in this case, we will stop when two hydrogens of this carbon is converted to chlorine. So we have carbon, 1Cl, 2Cl, and then there is hydrogen here. Okay, there is hydrogen here. Then what we do, we treat this with water at 373 Kelvin at high temperature. So water will have OH negative. Now OH negative का काम क्या है? It replaces the chlorine. So it will replace both the chlorine atoms, giving you CH. There will be OH and one more OH. Okay. Whenever you have gem diol, this is a case of gem diol. Gem diol means this carbon atom, it has two OH group. Whenever this happens, whenever this happens, this OH groups, they come up with them like this, and water is being removed. Okay, water is being removed in this case. So it will rearrange and it is going to give you CH is already here, double bond O. Okay, so basically this oxygen atom has lone pair electrons. This oxygen attacks here, it gets a positive charge. It breaks off, this hydrogen gives the electron here. But you can just remember, whenever there is two OH groups attached, then we are going to get aldehyde in that case. I think we have done this in the first class maybe. Alcohols के चैप्टर में याद है आपको? Alcohols के फर्स्ट क्लास में हमने बताया था. Either it was first class or the second class. See, whenever you have more than one OH group cannot be present in one carbon atom. As the molecule becomes very unstable, it releases H2O. So this carbon atom, it has two OH groups attached. So it becomes aldehyde. ठीक है? And it has one hydrogen and one CH3. तो वही वाला केस था यहाँ पे बिल्कुल. Okay. So here we have two OH groups attached and one is hydrogen. So it is going to get converted to aldehyde. Please write this down. Side chain chlorination is used like when you are going to have only methyl benzene, toluene के case में बस. Okay, this is also known as toluene if you don't know. Okay, benzene ring connected to a carbon atom. Write the seventh one, which is important, a named reaction. Gattermann-Koch reaction. It's a very easy reaction. You have benzene plus carbon monoxide in the presence of HCl and anhydrous AlCl3. This just gives you benzaldehyde. Now, statement for Gattermann-Koch reaction will be important because it is a named reaction. So please write, when benzene is treated with carbon monoxide and HCl in the presence of anhydrous AlCl3, it gives benzaldehyde. It gives benzaldehyde. Done. Once you're done, please write next. Method of preparation of ketones only. This is C part. Method of preparation of ketones only. Now, first of all, please write. Number 1. From acyl chlorides. Write the statement. When acyl chloride are treated with dialkyl cadmium, in the presence of dry ether, they form ketones. Right, next. How can we prepare dialkyl cadmium? Dialkyl cadmium is prepared by Grignard reagent and anhydrous cadmium chloride. Please write this down. Let me know once you're done. Then I will explain the reaction. Done, both of you? Yes or no? Please tell me.
Yes, sir.
ध्यान से सुनिए. I'm starting with a Grignard reagent RMGX. Plus cadmium chloride CdCl2 in the presence of dry ether. It will be CdR twice. ठीक है. यहाँ से R जो है, it attacked on the CD and it became CdR twice plus MgXCl. If you want to balance it, it will be 2 here. And yeah, now it is balanced. Or I think you will get 2 Mg here. Yeah. Okay. So this R group is attached to cadmium and this is known as dialkyl. Why dialkyl? Because you have two alkyl groups attached, dialkyl cadmium. Dialkyl cadmium. Now, Then we take some another alkyl group of acyl chloride. So we have acyl chloride and we react this R twice CD or CdR twice, whatever you want to write, in the presence of dry ether, same thing. Now, in this case, you will take 2 moles of acyl chloride. That is not important. Please remember, the number of moles बहुत important नहीं होता organic chemistry में. The product is important, the reactant is important, the reagent is important. Now, in this case, what happens? This chlorine, it gets substituted by this R group here. So we have R dash, C double bond O, and R. तो ये जो R है आपका, this R is coming from Grignard reagent. यार आ रहा कहां से? Grignard reagent से आ रहा है. ठीक है, इसको याद रखिएगा. So once you have 2, you are going to get 2 moles of ketones also, plus CdCl2. One alkyl group of ketone comes from acyl chloride and the other comes from Grignard reagent. I hope you have written the first reaction. Let's see a specific example now. For example, we have CS3MgBr and in the first case, we are reacting this with CdCl2. So I will get what I'm going to get. You just remember this, that we have wherever the CS3 is going, we have to write that product only. Don't worry about the byproducts here. So I'm going to get here CD CS3 whole twice. Now, if I react the CS3 whole twice with CS3 COCl, then I will be getting what? This C double bond here. This CS3 is coming from Grignard, this alkyl group, sorry, this acyl CS3 C double bond O. And then there is a CS3 which is coming from the Grignard reagent. ना यहाँ पे देखिए CS3CO ऐसे लिख दीजिए बिल्कुल. And what was attached on Grignard region? उसको देखिए CH2 and then CH3. इथाइल ग्रुप था आपके पास, तो इथाइल ग्रुप किसमें लग जाएगा? कीटोन में लग जाएगा. Please write this down. CH3CO is from the acyl chloride and the other alkyl group is from Grignard reagent. Okay, let's move forward. Right, next. From nitriles. Using Grignard reagent. Now please write both aliphatic and aromatic ketones can be prepared by treating an alkyl or aryl nitride with suitable Grignard reagent followed by hydrolysis. Now, starting with the simple example, let's suppose we have R dash MgBr plus we have some RCN. Okay, we have some RCN. Now, if you look at the CN nitride, carbon, triple bond nitrogen. So this carbon is already delta positive, right? It is very electron poor because nitrogen is connected with carbon atom. Nitrogen is very electronegative element. Now this R group is connected to a metal, that's why it is delta negative. So this R dash, it attacks on this carbon atom. This. So you will get R, C, R dash, and as soon as it attacks, it breaks a bond with nitrogen like this. You will get C double bond N, and then N will be connected with MgBr now. Once you add water in the presence of acid, you are going to get, see यहाँ पे, oxygen and two hydrogens like this. तो ये oxygen इसके पास चला जाएगा. So you'll get H3O plus, you will have R, C double bond O, R dash plus NH3 plus MgOHBr. ठीक है, plus MgOHBr. Write this down. Just a second. ठीक है, तो यहाँ पे भी आपके पास आर सी जो ये इतना पार्ट है, this part is coming from the nitride and the rest part R dash किससे आ रहा है आपके पास? R dash is coming from your R dash, it is coming from, अच्छा ये ऑक्सीजन नहीं आ रहा, सॉरी ऑक्सीजन तो वाटर के साथ आ रहा है, माय बैड. ऑक्सीजन को ब्लू कर देते हैं ना, पानी को भी यहाँ पे ब्लू कर देते हैं. Okay, so oxygen is coming from water, the RC is coming from the nitride and R dash is coming from the Grignard region. Write some specific reactions. एक काम कीजिए, ऐसे लिखिए इसको. फर्स्ट स्टेप में CH3CN, सेकंड स्टेप में H3O प्लस. तो यहाँ पे आपके पास CH3C डबल बॉन्ड O कहाँ से आ चुका है? CH3 और वाटर से आ चुका है. देन यू हैव इथाइल ग्रुप हियर, सो यू हैव वन कार्बन एटम एंड देन CH2 CH3. ठीक है, so this is the ketone. Furthermore, you can have some other, for example, if you have, आपको इस तरह से भी दिया जा सकता है, CN, फर्स्ट स्टेप में CH3 MgPr, सेकंड स्टेप में H3O plus, 1 2 3 कार्बन एटम, थर्ड कार्बन एटम with double bond O, and then you'll have CS3 from the Grignard reagent. If MJP are like this, first step में CS3CN, second step में S3O plus, write the CS3C double bond O, and then the Grignard reagent का alkyl group क्या है यहाँ पे benzene ring. So ये मिल गया आपको क्या? This is acetophenol. Please write this down. Done guys, आगे बढ़े? Yes.
sir.
Right, the last one, third. Friedel-Crafts acylation of benzene. Friedel-Crafts acylation of benzene. Please write. Aromatic ketones can be prepared by Friedel-Crafts acylation by treating aromatic hydrocarbon with acid chloride in the presence of anhydrous AlCl3. Simplest reaction. Let us suppose you have a benzene ring plus CS3 C double bond O Cl. The basic acyl chloride in the presence of AlCl3 and anhydrous AlCl3. We are going to get the benzene ring, then the carbonyl carbon, और उसके बाद जो attached alkyl group है. So you are going to get this part here. ठीक है? हमेशा से start कीजिएगा. Whenever you see CS3CO Cl in the presence of AlCl3 and aromatic, you will start benzene ring, then see the carbonyl carbon. Double bond O Cl, benzene ring, C double bond O. C double bond O के बाद इसके बाद कितने ग्रुप लगे हुए? 2 ग्रुप. तो 1 2 2 कार्बन atoms, right? You have the ethyl group. Right, next यहाँ पे भी AlCl3 होगा. Benzene ring plus you have benzene ring COCl. AlCl3 के प्रेजेंट में पहले बेंजीन रिंग लगाया आपने, then you add C double bond O. C double bond के साथ क्या लगा? Benzene ring. So just add benzene ring here. Write this down. Let me know once you're done. चलिए राइट क्वेश्चन। See, both of you wrote the question, yes or no? Tell me. लिख लिया आप लोगों ने, हनीफा एंड रिफत?
Yes, sir.
ठीक है, देखो। फर्स्ट ऑफ ऑल रीड द क्वेश्चन वेरी प्रॉपर्ली। व्हाट दे आर आस्किंग, गिव द नेम्स ऑफ रिएजेंट। उन्होंने कुछ नहीं पूछा, give the reaction. If they ask you to give the reaction, then you have to make the structure and give the reaction. But since they are only asking you to give the reagents, you don't need to worry about the structures here. You just need to give the reagents. So if you look at the first one, identify the class of compound here. So hexane 1-ol, what is this? It is aldehyde, ketone, carboxylic acid, alcohol, phenol, ether, haloalkane, halorine, alkane है, alkyne है, क्या है ये? What is this? What is the class of compound? Tell me. What class of compound is this? आप लोग समझ में आया हमने क्या पूछा? यस, रिफत आपको समझ में नहीं आया हमने क्या पूछा?
Understood.
तो फिर जल्दी जवाब दीजिए ना। अल्कोहल कहाँ देखना है आपको? यहाँ पे देखा कीजिए, ठीक है। लास्ट टर्म OL तो अल्कोहल। अल्कोहल से आपको क्या बनाना है बताइए?
Aldehyde.
वेरी गुड, दिस इज एल्डिहाइड। क्या यूज करेंगे बताइए? अल्कोहल टू एल्डिहाइड, व्हाट शुड वी यूज? व्हाट शुड वी यूज? अल्कोहल टू एल्डिहाइड। रिफत कम से कम आप तो बताइए, कल तो पढ़ाया ना हम लोगों ने, कल की क्लास का आपको याद नहीं है क्या? अल्कोहल टू एल्डिहाइड क्या यूज करेंगे? एक रिएजेंट हमने बहुत बार बोला है यूज करने के लिए, कौन सा रिएजेंट है?
PCC.
PCC। सेकंड बताइए फिर से कौन सा ये? अगेन इट इज अल्कोहल। फिर से अल्कोहल है, एंड अल्कोहल से क्या बनाना है बताइए?
Ketone.
क्या यूज करेंगे? व्हाट शुड वी यूज, टेल मी।
Oxidizing agent.
कौन सा ऑक्सीडाइजिंग एजेंट? रिएजेंट आपको बताना है स्पेसिफिकली कौन सा यूज करना है।
PCC और Na2CR.
हाँ ना, पीसीसी वो छोड़ दीजिए, ठीक है ना। वो सब याद रखिए। अगर आपको सवाल में दिया जाए CR2 यूज करेंगे तो क्या होगा, तब आप लिखिएगा कीटोन मिलेगा। आपको अगर पूछा जाए तो आप पीसीसी बोलिए, ठीक है। थर्ड केस, नाउ दिस इज इंपॉर्टेंट। पी फ्लोरोटोलुइन, पी फ्लोरोबेंजल्डिहाइड, यानी कि फ्लोरो का तो कुछ काम ही नहीं है ना। फ्लोरो इज नॉट अ रिएक्टिव साइट, फ्लोरो इज नॉट टेकिंग पार्ट इन द रिएक्शन। व्हाट इज हैपनिंग? टोलुइन टू बेंजल्डिहाइड, बताइए क्या यूज करेंगे? आज पढ़ा ये रिएक्शन। देयर आर 3 डिफरेंट वेज वी कैन यूज। हाँ बताइए हनीफा, जोर से बोलिए, आप साफ साफ बोलिए, माइक तो ऐसा बोलिए कि हमको सुनाई देता, आपको सुनाई ही नहीं देता है, बोलिए।
Chromic oxide.
क्रोमिक ऑक्साइड इन द प्रेजेंस ऑफ
CH3CO.
एसिटिक एनहाइड्राइड, ठीक है ना, बस वही लिख दीजिएगा। अदरवाइज यू कैन यूज क्रोमाइल क्लोराइड, ठीक है, वो ज्यादा आपके लिए आसान रहेगा, राइट। है कि नहीं? अब देखिए रिएक्शन, देखिए आप, CrO2Cl2, फर्स्ट स्टेप में CrO2Cl2, सेकेंड स्टेप में क्या है, याद कर लीजिए आप, H3O+, ठीक है, ईटार्ड रिएक्शन। whenever you have a alkyl benzene, आप ईटार्ड रिएक्शन के लिए याद कीजिए, ठीक है ना, because you just have this two to remember. Acetic anhydride is a big molecule, अगर आपको शायद याद ना रख सके। Now what about this one? Nitrile to aldehyde, क्या यूज करेंगे? आज पढ़ा था हमने, नाइट्राइल टू एल्डिहाइड, बताइए, आज पढ़ा है ना हमने, नाइट्राइल टू एल्डिहाइड क्या यूज? डाइबाल एच, उसको क्या बोलते हैं? डाइबाल एच ही बोलते हैं, ठीक है। सेकेंड स्टेप में पानी, हाँ, वाटर या H3O+ डाल दीजिए। देन यू हैव, अगेन बताइए, अल्कोहल से एल्डिहाइड क्या यूज करेंगे? PCC। सिक्स्थ में ब्यूट-2-ईन टू इथेनॉल, ये रिफत बता पाएंगे? अगर हनीफा ने पिछले क्लास को रिकॉर्डिंग वगैरह देखा आपने तो वो आप बता पाइएगा, वरना नहीं बता पाएंगे। हनीफा बताइए क्या यूज करेंगे? एल्कीन है आपके पास, एल्कीन से एल्डिहाइड, और यहाँ पे आपके पास 4 कार्बन एटम्स हैं, यहाँ पे 2 कार्बन एटम है, तो ऑब्वियसली देयर इज ब्रेकिंग ऑफ कार्बन कार्बन बॉन्ड। कौन सा रिएक्शन होगा बताइए? एल्कीन कहाँ पे, एल्कीन वाला कम से कम आइडेंटिफाई कीजिए आप नोटबुक में देख के। हाँ रिफत जल्दी बताइए।
सर डाइल्यूट H2SO4।
डाइल्यूट H2SO4 ना, एल्कीन बोल रहे हैं ना, एल्कीन में डबल बॉन्ड होता है, देख के तो आप सही बताइए रिफत। मेथड ऑफ प्रिपरेशन में जाइए, टॉपिक में एल्कीन होगा, उसके बाद ही ना आप कुछ बता पाइएगा, टॉपिक में जाके देखिए एल्कीन में क्या है, अंदाजी मत बताइए, ठीक है। ZnH2O है, पूरा बताइए ना, पढ़ के बताइए, पढ़ ही नहीं है लग रहा है आप तो। क्या है बताइए, कौन सा रिएक्शन है, क्या टॉपिक का नाम क्या है बताइए?
ओजोनोलिसिस ऑफ एल्कीन्स।
ओजोनोलिसिस में क्या रिएजेंट सबसे पहले क्या डालते हैं?
O3।
नहीं लिखा है, O3 डालते हैं ना, तो फिर आप ये सारी चीजें क्यों बोल रही हैं ऐसे, आधी आधी चीजें क्यों आप बोल रही हैं? ZnH2O, ठीक है, O3, and then in the second step we are going to use ZnH2O। क्लियर है? yes or no? ठीक है, राइट, नेक्स्ट। फिजिकल प्रॉपर्टीज, right here, aldehydes and ketones are soluble in water as they form hydrogen bonds with water। कैसे? कार्बन डबल बॉन्ड ऑक्सीजन, so the carbonyl carbon has, carbonyl carbon का ऑक्सीजन जो है, it has lone pair electrons and both of these hydrogen of water will be very delta positive। So the lone pair electron, it interacts with the delta positive, the electrophilic, the electron poor hydrogen atoms of water, and that is why they are forming hydrogen bond। But if I'm going to increase the whatever R groups will be present here, right? If it is aldehyde, there will be R groups in both the side. If it is aldehyde, it will be R group in one side and hydrogen in the other side. Okay, that means there will be alkyl groups also present। So if I'm going to increase the number of carbons in the alkyl group, if the alkyl chain increases, then solubility will decrease, because alkyl chain is not participating in hydrogen bond, only carbonyl carbon is participating। Alkyl chain is non-polar, and since it is non-polar, it is what? It is not favorable for solubility। So please write solubility of aldehyde solubility of aldehyde and ketones decreases rapidly with increase in length of alkyl chain. Increase in length of alkyl chain. Right, next. The boiling point of aldehyde and ketones are higher than non-polar hydrocarbons and weakly polar ethers. Next. However, due to absence of hydrogen bond within aldehyde and ketone, within aldehyde and ketone, their boiling point is lower than corresponding aldehyde. Oh, sorry, corresponding alcohols. So now we can conclude the highest boiling point will be for compounds which have hydrogen bonds, such as alcohols and phenols. After that, there will be polar molecules, such as the aldehyde and ketones. After that, there will be weakly polar. Weakly polar are ethers, and then there will be non-polars. Non-polars are alkene. Okay, so this is the order of boiling point. If intermolecular force of attraction is hydrogen bond, then it is going to be having the highest boiling point. Write a question. सवाल लिख लिया आप लोगों ने? हाँ या नहीं, जल्दी बताइए. हनीफा एंड रिफत, सवाल लिख लिया?
1 minute.
Okay. So tell me, A structure is what? What class of compound is this? क्या है? Halocene, halorine है, aldehyde है. Second one is
alcohol,
alcohol. Third one,
ketone,
ether. Fourth one is
alkyl,
alkene. Fourth one is alkene. Now aldehyde is having intermolecular force of attraction, which is polar. Alcohol will have, tell me what? इनमें से क्या होगा alcohol के पास? Alcohol अल्कोहल में होता है हाइड्रोजन बॉन्ड. ईथर इज वीकली पोलर, आज लिखाया है. Alkene, these are always non-polar. Whenever you have any hydrocarbon, it is going to be non-polar. So the highest boiling point will be of B, followed by A, polar, followed by weakly polar C, followed by non-polar D. Please write this down. Done, guys. Yes or no? Please tell me. लिख लिया आप लोगों ने? ठीक. Okay. Now, write next chemical properties of aldehyde and ketones. Chemical properties of aldehyde and ketones. I'll start with a reaction, that is addition of ammonia and ammonia derivatives. In that reaction, I will explain one, and similar pattern you will see in all the ammonia derivatives. Okay, so please write first of all. Addition of ammonia and ammonia derivatives. Now, first of all, see the carbonyl carbon. You have C double bond O, and there will be some groups attached to this carbon atom. Okay, there will be some groups attached to the carbonyl carbon. You have C double bond O and some groups attached here. This carbon atom, it is what? It is very delta positive because it is attached with oxygen atom through multiple bond, and oxygen atom is what? It is electronegative element, and it is pulling the electron. That is why this carbon is going to be delta positive. Then we have NH3. NH3, please remember, it always have a lone pair. It has 3 bonds and a lone pair. When it has 3 bonds, it will have 1 lone pair. Now this NH3, it is what? Electron rich. It is a nucleophile, so it will attack on this carbon atom. And as soon as this attacks on the carbon atom, nitrogen atom, it attacks on carbon atom. That means it is going to form a bond with carbon atom. So carbon atom, it already has 4 bonds, so it will break the pi bond with oxygen, and you will get whatever groups are attached to carbon atom as it is, single bond oxygen with a negative charge, and you will get nitrogen with 3 hydrogens and a positive charge on nitrogen. Now, when nitrogen is going to have positive charge and nitrogen is an electronegative element, it is going to pull electrons from hydrogen, making all the hydrogens very delta positive. Now, since the hydrogens are delta positive and this oxygen atom is negative, The oxygen atom is going to attack on the hydrogen atom like this. As soon as this oxygen attacks on hydrogen, hydrogen will say that I will not need your electrons, nitrogen. Please take your electron. And it is going to give the electrons back to nitrogen. So nitrogen gains 2 electrons and neutralizes the positive charge. So you have carbon, whatever groups are attached to this are attached as it is. Then you have oxygen, and it is attached with 1 hydrogen here. Now here nitrogen, it is attached with 2 hydrogens. But still the hydrogen atom, these are having what? Very high electron. These are having very high electron sink. That means they are very electrophilic. Electrophilic means delta positive here also, delta positive here also. Now oxygen atom, since it has lone pair electrons, so it can still attack. And as soon as this attacks here, this hydrogen atom says that, okay, fine, you can attack me, but I'm going to give the electron back to nitrogen atom like this. So when it gives the electron back to nitrogen atom, you will get carbon, oxygen with 2 hydrogens and a positive charge. Now this nitrogen is having only 1 hydrogen with a negative charge, and there are 2 lone pairs on nitrogen atom. Now oxygen atom gains a positive charge and it leaves the carbon with water molecule. So water is left, and you have carbon. Whatever bonds are attached to it is attached as it is. Then you have a double bond. This, as soon as this water leaves, this nitrogen atom gives the electron to carbon. Double bond nitrogen and hydrogen like this. So it neutralizes its negative charge by forming a bond with carbon atom, and it has 1 lone pair. So what you can see from here is, you can write it like this: C double bond O, and you can write NH3 as nitrogen with H and 2 other hydrogens like this. Now these 2 hydrogen atoms, they form water with the carbonyl carbon, and the product is C double bond nitrogen and hydrogen. All of these reaction mechanism, you don't have to learn the reaction mechanism, but I have shown what is happening here. The important thing that you have to learn is this part. Important thing is this, you have to learn this part. This is the general scheme of reaction that you have to follow in ammonia. This is for ammonia and for ammonia derivatives also. Okay, so please write this down and then also write this particular blue part. ठीक है, जिसको भी लिख लीजिए जो आपको हमने इस बक्से के अंदर रखा हुआ है. ठीक है, also write this part. This is important, how to make the product. Please write this down. Let me know once you're done. Yes, everyone done? Yes or no, please tell me. Rifat and Hanifa done?
No, sir, just
Okay.
no, sir.
Now see, in general you will have carbonyl carbon तो होगा ही हमेशा, two groups plus the ammonia derivatives will be in the form of NH2 and one of the bond will be with some Z. तो जैसे कि यहाँ पे Z क्या था, हाइड्रोजन था. ओके, सो व्हाट विल बी द प्रोडक्ट, आपके पास यहाँ पे प्रोडक्ट बनेगा इन जनरल कार्बन डबल बॉन्ड नाइट्रोजन. ठीक है ना, कार्बन डबल बॉन्ड नाइट्रोजन तो तुरंत ही बना देना आपको, एंड फॉलोड बाय Z, followed by Z. So I will give you some questions. You have to identify the Z. Please write. For example, NH3 था. So if you have NH3, you don't have to look NH3 in this manner. You have to see nitrogen with two hydrogens. हमेशा दो हाइड्रोजन को अलग कर दीजिए, उसके बाद जो बचा है that is your Z. So you have remaining hydrogen. So what is the Z here? The Z is hydrogen here. Okay, Z is hydrogen here. Second case, NH2OH. May you will tell me what is the Z? You have NH2, NH2 hydrazine. चलिए इन चारों में बताइए. So Hanifa, what is the Z in the second one? Tell me. थर्ड वन में क्या है?
NH2
फोर्थ वाले में
and
नहीं. देखिए NH2 आपने हटा दिया तो NH के बाद बेंजीन. ठीक है ना, ध्यान दीजिएगा. You have to remove NH2. NH2 को साइड कर दिया आपने, उसके बाद आपके पास बेंजीन है. तो फॉर एग्जांपल you have ethanol plus NH2 NH2. Then you're going to get CH3 carbon double bond N and then the Z is what? NH2. और यहाँ पे एक हाइड्रोजन as it is. Similarly, if you have CH3, मान लीजिए आपके पास एल्डिहाइड नहीं है, कीटोन है. NH2OH. तो कार्बन डबल बॉन्ड नाइट्रोजन तो देना ही है, उसके बाद जो Z है, व्हाट इज द Z? OH. Here also कार्बन डबल बॉन्ड N तो देना ही है, क्योंकि जो है आपके पास अल्काइल ग्रुप, अगर मान लीजिए ऐसे रहता तो आप यहाँ पे एक और कार्बन इस तरह से जोड़ देती. ठीक है ना, तो उसको ध्यान रखिएगा. वॉट एवर दी कार्बोनिल कार्बन इज देयर, उसी वही स्ट्रक्चर. ऐसा नहीं कि आप सब में यही बनाने लगे. You have NH2 attached here. Okay, so please write this down. These are some structures, and then we will look at specific reaction of there are 7 different ammonia derivatives. We will look at them in detail in the next class. Okay, अभी के लिए इसमें यहाँ तक लिखिए and let me know once you're done. Done, Hanifa?
Yes, sir.
Just a minute.